Welcome to the first installment of Geometry at Home. Today we're looking at section 1.1, which is entitled Getting Started. And the whole point of this section is to become familiar with a bunch of terminology that we're going to use throughout the year, specifically points, planes, segments, angles, triangles, all that other good stuff. We're going to start off with a definition, and a point is a location in space. Now, again, this is what a point is going to look like, or at least how we draw it. Points don't actually have dimensions. They're just represented by dots. The way we name points, we're going to use a capital letter, and it's very important that you use capital letters so that we don't confuse them with other quantities. In this case, the points are labeled A, B, and C. We also have a plane. A plane is a flat surface that extends in all directions infinitely. And what that means is it's going to extend to the left and to the right, up and down, and also on diagonals. This is what a plane is going to look like. You'll notice that we have those same points that we had before, but now we also have a cursive capital letter, which we'll get into in a minute why we have that. Examples of planes include the chalkboard in a classroom, a wall, floor. All those things are planes. They're flat surfaces that extend in all directions. So the way we name a plane is we've got two options. One option is we can use three capital letters, any three capital letters that are on that plane. In this case, I've only labeled A, B, and C, so I can only use A, B, and C to name it. Or we can call it plane P, using, again, that uppercase cursive letter. Within this, kind of connecting those two ideas, we have the coordinate plane. Now, you've seen this in Algebra 1. Here's what it looks like. You'll notice we've got a grid with a bunch of different values here. We have an x-axis. We have a y-axis. So each of these points is going to have a coordinate. It tells us a location in space. The first coordinate is your x value. So if you're looking at our x-axis, point A is 4 away from the point 0, 0. This point 0, 0 we call the origin. It's a very important point. The second coordinate, this 2, is the y value. So to graph this point, we would go over 4 on the x-axis and up 2 on the y-axis. And you'll notice that in quadrant 1, this is this first area right up here. That's the pen. There goes the pen. Our values of the coordinates are all positive. So we have a positive x value and a positive y value. In quadrant 2, if we're moving in the counterclockwise direction, this is quadrant 2. And you'll notice we're using Roman numerals for this. We have a negative x value and a positive y value. It's a positive y value because we're above the x-axis. And it's a negative x value because we're to the left of the y-axis. Continuing our pattern, we're down to quadrant 3. And we have a negative x value and a negative y value. And then finishing it off, we're in quadrant 4. And we have a positive x value and a negative y value. Now we're going to do a lot more with that later, but for now just kind of a basic introduction to the coordinate plane. Again, how do we name the points? We're going to name the points using our x coordinate followed by y coordinate. It's always an ordered pair, two together. If we have a bunch of points and there's a beginning and an end, we have what's called a line segment, which we're going to define as a set of points with two endpoints. So this is what a line segment will look like, and a lot of times we'll just call it segment because it's really the same thing. But we have 2 points A and B. Now which one is the beginning and which one is the end? Well, we're not really sure. So we call them endpoints because it really doesn't make a difference which is the beginning or the end. We could flip-flop it and it's still referring to the same thing. So how do we name it? Well, we use capital letters for the endpoints because we're using points, and we'll name it like this. We have segment AB or segment BA. Now you'll notice here once we've got this named, the shape is right above the points. So if we're using point A and point B and calling it a segment, we're going to draw a segment. And that's really one of the important things from this section to know is if you're referring to a segment, call it a segment. Don't call it something else. Array is a set of points that has a beginning, but it doesn't have an end. So it's kind of like a segment, but it's going to keep on going. So this is what array looks like. It's array OK. O is our beginning point, and that's very clearly, hopefully, a beginning point because there's nothing before it. And then we have point K that is on the array, but it's not where it stops. It's going to continue on forever, and that's what that arrow means. So how do we name array? Well, we use capital letters, just like we did with segments, because we're using points, followed by, with the beginning followed by another point on there. So in this case, this is called array OK, because we start at point O, we go through K, but we don't stop. And notice, just like with a segment, the type of geometric shape that you're drawing is part of the name. So OK, we have array above it. That's what array looks like. So it's segment O, or array OK. But it's not KO, because KO would be saying we started at K and went towards O. So our arrow would be pointing this way. And that's not exactly what we have. Now later on in section 2.8, I think it is, we're going to talk about vertical angles, and we're going to have what are called opposite rays. And an opposite ray is going to be the same thing as OK, but instead of stopping, it's going to go in an opposite direction. It's called an opposite ray. Eventually you'll see exactly how these are used with vertical angles, but that's not until section 2.8, so we've got some time. If we had a ray, but instead of going in only one direction and went in two directions, we would have what's called a line. And a line is a set of points that has no beginning or end. There's no distance, there's no measurement for it. We can't say a line measures 7. It doesn't. There is no measurement. So how do we name these? Well, there's a lot of different ways that we can name these. You notice with a segment, we had to use the beginning and the end as our name. For a line, it's a little bit different. We've got two options here. One is to use capital letters in any 2 points, and the other option is to use a lowercase cursive letter. We'll do that more in chapter 5, but for now we're going to use the capital letters in any 2 points. So examples of what I could name this line: I could name it line CT, I could name it line TC, I could name it line CA or AT. Any 2 points that are on that line I can use. And the reason I can use any 2 is there is no beginning and there is no end, so I can't specify which is which. The other option here is to name it with the lowercase cursive letter, and that's that L that we've got. An angle is a figure formed by 2 rays with a common endpoint. This is a very important point. I'll pull up the picture here for you. We have O as our vertex, and I know that's the vertex because that's where ray OD and ray OG are going to intersect. That's where they meet. And you'll notice that the vertex does not have any arrows or anything like that on it. So the way to name an angle, we've actually got 3 different ways we can do it. So one option is to use 3 points with a vertex at the center. Another option is to just use the vertex. And I want to caution you on this, you can only use this when it's very specific which angle you're talking about. If there's 4 different angles that have an O as the vertex, you cannot call it angle O. I don't know which of the 4 you're talking about. Or you can use a number. So using 3 points, we have angle DOG. Notice here that we are using the angle symbol. If you're talking about an angle, put an angle symbol. Same here with angle GOD. And what they both have in common is that O is that point right in the middle. That's the vertex. Option 2 was to use just the vertex. Angle symbol again, it's angle O. And the other option is to use a number. Now, this number 1, it's just the name of the angle. It is not the measurement of the angle. It's not a 1-degree angle. We're just calling it angle 1. It's a little unusual to call something a name by number, but that's the way it is in angle measurements. Alright, the last definition we're going to talk about today is a triangle, and that's a 3-sided polygon. And here's what it looks like. And you're going to use 3 vertices to name a triangle. So we want to name the triangle in all possible ways. Now, I didn't tell you a specific way to name this. What you're going to do is you're going to look at the 3 different points that make up the triangle and use them in any order. So to name this, I could start with G and then go to E and then O, or maybe I wanted to go from G and then O to E, or maybe I wanted to go from O to G to E. I've got a lot of different options. I've got 6 different ways that I can name this. But you'll notice in all of the naming, triangle symbol, all the way throughout. All of them have that triangle symbol. And that's something you got to be really careful of early on, is forgetting those symbols. When we get to chapter 3, the naming of the triangle, the specific order, is going to be very, very important. For now, it isn't. Just name it with those 3 points and we're good to go. Alright, kind of the meat and potatoes of this section, the union, intersection, putting it all together. So what happens when we put something together? That's what a union is. And the symbol that we use for union is that U shape. You can easily remember this, that union is U. It's the same exact letter right there. An intersection, if you think about when 2 roads intersect, it's usually that area in the middle. We want to know, what do they have in common? Where do they overlap? And it's like that U symbol, but we've completely flipped it upside down. So intersection is kind of like the second letter, N, and they're almost the same exact thing. So a quick example with union and intersection, and then we'll get more in depth on it. Here's what appears to be an angle. If I have this, AR, that means ray AR, union, put it together, with ray AY, that means I'm putting the 2 rays together. And that gives us an angle. If you put 2 rays together, you get an angle. And A is the vertex. The second part, though, AR intersection AY, means what do they have in common? Where do they overlap? So I'm looking for a point where they have, or well, something that they have in common. So I highlight AR, and let's try a different color here. There we go. We'll go blue. And then I have AY. So I'm looking for what they have in common. It's right there. It's that point A. That's what they have in common. Alright, so looking at what we've got on this particular slide, it says find the following. We want to find, for part A, we are going to do the union, put it together, of SD and SR. So I'm going to highlight SD, and then I'm going to highlight SR, back to our trusty yellow, and I want to put them together. So when I put them together, I get an angle. And it's angle DSR or angle RSD. They're really the same thing, but the only difference is the order that I have named them. And that's okay, because they both have the vertex at the center. For the second part, I'm looking for the intersection of line DA. It's tough to draw a straight line with the mouse here. And WR. That's a little, not so good. We're looking for the point that they have in common, right there. Point S. Okay, and then our next one is the union. This should be a dead giveaway because of what we've got here. The union of these 3 things right here. We have RS and SA and RA. And hopefully you can see from that picture that we have a triangle. Triangle RSA, SRA, however you want to name it. Make sure you use the 3 points. For the next one, we have the intersection of line DR. Oops, let's try that again. There we go. So line DR. And we also have line WA. And it appears to me that they don't intersect. And I'm going to be very careful not to use the word parallel, because I don't know that for sure. But based on the picture, there is no intersection. So I'll say none. And then the last 2 I think are the more challenging ones. We have the intersection of WR and SR. So I've got WR highlighted, now I've got SR highlighted. I'm looking for what do they have in common. What they have in common is this segment right here. And that's segment SR. Notice it's a segment, it's got a beginning and an end. And for the last one, we want the union. So what happens when we put them together? Again, we get a segment, beginning and an end, but now it's the entire segment WR. And that's all for the notes.